Hi guys, Audrey here, and this is a JAC capsule on factoring. In this video, we're going to look at a formula that allows us to determine if a quadratic polynomial is irreducible, that is, if it cannot be factored. Let's get to it. So in this video, we want to check, is the polynomial ax squared plus bx plus c irreducible? Note that this only works for quadratic polynomials. So the fact that that's a 2 there is important. The a here could be 1 or it could be not 1. So this works for both monic and non-monic quadratic polynomials. So in order to determine if it's irreducible, we're first going to remember the quadratic formula. So the quadratic formula allows us to find the roots of this polynomial or the zeros of this polynomial. The x values that we could plug in, that would make 0. And those are the values that we use for factoring. So the quadratic formula here is the opposite of b, so negative b, plus or minus the square root of b squared minus 4ac, all divided by 2a. And what I want you to notice about this formula is that under the square root, we have b squared minus 4ac. And that's going to be our key for determining if this is irreducible, because anything under a square root cannot be negative. So if b squared minus 4ac is less than 0, then ax squared plus bx plus c is irreducible / cannot be factored. So that b squared minus 4ac is key. If, however, it is greater than or equal to 0, then the polynomial can be factored. Now, that doesn't mean that it can be factored easily. Perhaps the factors are like 2/3 and pi, right? It doesn't necessarily mean that, hey, I'm going to be able to look at this and do product sum and find the factors and factor this nicely. It just means that it has zeros, that it's possible to factor it. So with that in mind, let's take a look at two polynomials and try to apply this formula. So first, we're going to look at 3x squared plus 2x plus 9. And then we're going to look at just x squared plus 2x minus 9. So I want you guys to use this formula to check whether or not these polynomials are factorable. Are they factorable or are they irreducible? Now, if they are factorable, don't bother factoring them. Pause the video, use the formula, check, and then come back. All right, so let's look at this first one. Here my a will be 3. My b is 2, and my c is equal to 9. So when I apply b squared minus 4ac, I get 2 squared minus 4 times 3 times 9, which is 4 minus 12 times 9, that's 108, which gives me negative 104, which is less than 0. So this polynomial right here is irreducible. That means I cannot factor it. There are no x values that I could plug in that would cause this to be 0. Now let's look at this other one over here. Here, my a is 1, so this one is a monic polynomial. My b is 2, and my c is actually equal to negative 9. So it's important to remember to take the negative with you. Now, if I plug this into the b squared minus 4ac formula, b squared minus 4 times 1 times negative 9, that gives me 4 plus 36, which is 40, which is indeed greater than or equal to 0. So this is factorable, or we could say not irreducible, or we could even say reducible. Now, again, like I said, that does not mean that it has nice, easy factors where we could do product sum. And in fact, in this particular case, product sum would fail us. The reason for that is this thing right here is not a perfect square. When this value is not a perfect square, meaning that the square root of 40 doesn't equal to some nice whole number, not a perfect square, that means hands down, I'm not going to be able to find nice values to factor. If it is a perfect square, I can find nice values, but that doesn't mean that product sum will always work because potentially one of those nice values could be 2/3 or something else fractional that might be challenging to find if you're doing the product sum method. However, if it's not a perfect square like 40, then your value is definitely going to be a radical of some sort, like the square root of 40 will be involved. So we're not going to be able to factor this easily. So 40 is not a perfect square. So this does not factor easily. So with that said, if ever you're looking at a polynomial and you're just like, I don't know, I've tried product sum, it's not working for me, use this thing, b squared minus 4ac, to see if it's even worth your time, because maybe it turns out the polynomial is irreducible. All right, that's all. Bye, guys.